Hi everyone, and welcome to this week's Google's Developers Live for Google Drive. I'm Stephen Basil, joined here with Ali Afshar.
Hi.
And today we are going to talk about a couple of tips that you can use to increase the performance of your application and your integration with Drive. These are going to be a couple small things, but they are pretty important and can actually have a pretty dramatic impact on how your apps perform. Let's start with a really simple one. We have in the API a couple of different operations, right? Your standard RESTful API, and we have a verb for patch.
Right.
And for those who don't know what patch is, it's a way of doing partial updates for a resource. So you can only send the modified fields. Small bit of advice, don't use it. It's really simple. Actually, the way the Drive API works, you can just do a regular update on a resource with sparse fields, and it will work fine. Do you know why it actually ends up being more efficient?
So I have an idea, but just to get it correct, you have files, and then you only have a few of the values that you want to update in the.
Sorry. I'm just trolling Ollie here.
So you have a file that you want to update to Google Drive, and you've only got some of the parameters you want to actually update. So you've only got the title, you've only got the description, you don't have everything. Now that's what patch exists for, is so that you can send just a few of these. But actually in the Drive API it doesn't make any difference. You may as well update with an impartial or sparse file, as you say.
Right, exactly. And this actually turns out to be kind of a small internal implementation detail for how patches work, because we actually end up having to reread the entry back. So it actually costs us a little bit more. In terms of actual performance, it's not going to make a huge difference for your application, but it is a lot more resource efficient for us if you just do a regular update.
Okay.
And I'm glad that we'll have some GDL bloopers for after. We're just in a very giddy mood today. So anyway, the next one is batching requests. So batch is a way that you can bundle multiple requests together into a single API request. You can use it for all sorts of things, with the exception of uploads. But that aside, you actually still have a lot of options. And there's a couple of really good use cases for things like if you're listing the contents of a folder and you want to then expand things like the custom properties or the ACLs on a file, which require separate calls. If you have, say, a page of files, say 20 files for a page, you can then batch up the subsequent request to expand out whatever additional properties you want. And that actually has a nice benefit in that it does a couple things for you. So one is a little bit less overhead in the HTTP requests. So all the headers that you would normally send, plus the fact that you're usually setting up and tearing down a connection each time. There's a lot of overhead. The other one is, while you can do the parallel request yourself, you can certainly do a whole bunch of async requests and then gather up the results. The batch actually just handles all that for you. And this is implemented in our client libraries in a way that makes it super easy to do a whole bunch of parallel requests together.
And that's interesting, because in our old APIs, if you ever use the documents list API, for example, you could only batch the same type of request together. So you could say, I only want to batch 50 GET requests in a single batch. But now with our newer Drive API, you can actually batch different types of requests.
That's true, right? You could actually update 20 files all at the same time. So if you wanted to add a description or some properties to a set of files, you can actually do those very efficiently. One catch: these do actually count as separate requests from a quota perspective. And while you can certainly do batches of up to 1,000 requests, if you were to try to do it, you'd actually start to run into your QPS limits for an app and for a user. But still, it's a useful technique for certain use cases where you know that you need to do a whole bunch of operations, and you need to do them roughly at the same time, and do that very quickly. So another one is partial updates. This is something that we did a blog post about just last week. And this actually has probably the biggest impact on application performance and your bandwidth utilization. So one of the things you can do is, when you're calling the Drive API, is you can, via a query parameter called fields, list which fields that you would like returned. And I did some testing on this, just using the common use case of listing the contents of a folder, and found that you could actually get about, for a common use case, about 90% reduction in bandwidth. And so that's huge. It's so I went from something like 380K down to 30. Actually, it was even less than that. Throw in gzip compression. Then it goes from 30K down to about 7. So it's actually pretty important. And I've heard from a few people in the community that this actually has a little bit of a financial impact. If you're, cases you're buying bandwidth and so on.
I mean, that's the whole point of this. Make fewer requests, that's going to cost you less. Send less data, that's going to cost you less. Receive less data, that's just going to cost you less. So, I mean, we don't want you to pay more money for the stuff. I mean, that's the main thing.
Yeah, and the nice thing is, I mentioned gzip compression. Gzip compression has a cost in terms of CPU usage. We certainly still encourage it, but if you are very sensitive to CPU, then another way that you can reduce your bandwidth is by limiting the amount of data that you send back in the first place. There are some upcoming changes I think that we're working on in the back end that will actually make this not just faster from a bandwidth perspective, but actually faster from the amount of time that it takes to actually execute the queries, to serialize the data into a response. And so over time, this is just going to get better and better for users.
So right now on the back end, we fetch all the data and then selectively send you some back. Isn't that's the problem?
Exactly, right. And and it's just the way things are stored is actually very time consuming to go and assemble all that data. But now with these hints, we can do a lot of optimizations to make sure that we get results back to you as a developer a lot faster.
So if you just want to list the titles of the files in a list, you just ask for the title.
Exactly. You did that, you would probably save about 95% of the actual data would just be completely eliminated from the network.
And to see how to do that, check out Steve's blog post.
Yeah, it's really easy. All the API clients support it. And again, it's just a query parameter. There's a little bit of an odd syntax because these are structured responses. So if you have nested collections, there's a syntax for how you would enumerate which collections and which properties of those collections. But this is all documented pretty well on developers.google.com. The last one, which doesn't necessarily connect back to performance quite as much, is just proper error handling. And so there's a couple different cases for errors. So some of the common ones, you get things like you're unauthorized, you may be rate limited, so that'd be a 403 response, and you also run into occasional 500 errors. These aren't necessarily things that you can control when you hit a 500. It's usually some intermittent error, timeout, heavy load on our side. But how you respond to those errors can actually have an impact, particularly in the case of high load situations. So what are some of the strategies people should use for retrying on errors?
So in general, retry on errors. I mean, I think that's a general point because sometimes, as you mentioned, intermittent errors and that kind of thing, but the API, is a massive distributed system, and we kind of expect you to retry.
Right, but you don't want to just retry immediately, right?
No, exactly.
Otherwise, we're just going to hammer the server, and things aren't going to improve.
Yeah. So as always, you should use an exponential backoff. So try again in an exponentially increasing amount of time. Add a little jitter, of course. And yeah, just do it. Usually it will succeed. And you'll see if you check out Stack Overflow, occasionally people do get these errors and they're fixed just by retrying. So
yeah, exactly. One thing is don't, on that initial retry, make sure you put in a delay. It should be, at least a second. Obviously, if you're doing things in user time, you don't want to go too long of a delay. But if it's something more programmatic, you're doing a background job, you can actually even back off a little bit more aggressively and give the system time to recover. And the jitter is actually really important. And for those who don't know this concept of jitter, it's basically adding in some randomized value into that delay. So if you just did a fixed exponential backoff, you might do a delay of 1 second and 2 seconds and 4 seconds and so on. The problem is if you have a lot of threads doing this and they all happen to hit the same error at the same time, well, they're all going to retry at the same time. And you end up in this kind of wave, a cycle of servers just getting hammered by all these clients acting in lockstep. adding a little bit of randomization gives gives those clients a little bit of time to kind of differentiate and get onto a different period for when they're going to retry and start to smooth out the traffic a little bit more. So, a reasonable value could be, maybe 10%. Just pick a random value and then add or subtract. But it'll make things recover a lot faster if you have those types of things. So, are there any other things you can think of that would help people? So there's low-level things like gzip and so on that people can do, but those are usually taken for automatically by the client libraries.
So those are the things. Remember, batch requests, catch errors and retry. Partial fetch is really important, so passing the fills parameter, just get back what you want. And patch sounds like a good idea, but it's probably better to just do a partial update at the time. But those are our things. And remember why you do this. It just saves you bandwidth, it saves you time. And sometimes it saves us time, which obviously isn't your main concern, but it just means you get the request back quicker, which is obviously going to be good. You get better latency in your applications, so that's good.
Yep. So that's all for this week. Next week, I am not entirely sure if we have our topic set for that. We may actually skip, but we'll be back certainly the week after for our normal schedule with apps of the week, and hopefully a few guests. We'll actually be out next week, and until then,
thanks very much.
Thank you all for coming.
Bye.